thing. Okay, let me explain to you once again. So the Lamport-Shostak Pease algorithm is for more than three processors. That is 3M plus 1, 3M plus 1. So P0 is sending, so in this example, P0 is not the faulty control site, okay, or a node. P2 is the faulty one. So wherever the dot has been represented, these are the faulty ones. So P0 is sending a message 1, 1, and 1. Here the faulty one, he will send 1 to one processor, 0 to another node. So it it varies. Okay, so it varies. The faulty node always they differ from the value what it has been sent priorly. Okay, so or previously to the other node. Okay, let us move to the next one. How these communications are happening. Okay, so you can understand here. So P0, 1, 1, and 1. He is sending three ones. Okay, he is sending three ones. You can understand this particular point. Okay, so he is sending 1, he is sending 1, and he is sending 1. You can see here P2 on receiving of 1, P1 is sending 1 to P2, and he is sending 1 to P3. Okay, and P2 receiving 1, he is sending 1, and he is sending 0 to P3. So he is sending a wrong value. He is sending a wrong value. So that is how the faulty nodes will communicate to the other node. And this place there is a conflict. Okay, this place there is a conflict. So to avoid this confusion, so again, if you see this one, what we are going to do, we are going to take the what you can say the values. You can understand here. We are going to take all the set values, whatever the message that has come from all the other nodes. So P1 is receiving 1 and 1 and P3 1. So the maximum of this 3, okay? So maximum of this 3, okay? So this is going to be 1. So then from P2 is receiving 1 and is receiving 1 from P1 and from P3 also 1. So the maximum of this is 1. And here P3 you can see it is 1 and from 0 from P2 and 1 from P3. I mean P2, sorry, P1. Okay, P0 1 and P1 is 1. So maximum value 2 ones and 1 1 0. So maximum is 1. The same way here you can see this fellow is the faulty one. Okay, the dotted ones are faulty one. So here you can see he is sending 1 to P1 and he is sending 0 to P2 and he is sending P3 1. But if you see this calculation, once you receive the message, all the messages, and if you create the maximum value if you found, so here it is going to be 2 ones and 1 0. So maximum is 1. And the P2 0, 2 ones, and is going to be 1. And here it is 1 0 1 and 2 ones are there. So maximum is 1. So site 2 and this is site 1. So they agreed upon a common value 1. Okay, then only they can do a communication. Suppose here it is 1 and here if it is 0, they will not agree upon this communication and there will be a conflict between the the communication. So they will not send any messages between the sites. I hope you have understood. This is the agreement protocol. And the one basic idea is the Byzantine algorithm and the consensus and interactive, almost interactive. What we have done is what we have discussed in the Lamport, Lamport algorithm. If you see this one, the Lamport exercise is nothing but we have discussed the same thing. The Lamport-Shostak Pease algorithm. We have exactly discussed about the interactive. The third type of the algorithm. What we say, interactive consistency problem. So we are taking all the messages which is coming from all the nodes. Are you following what I'm saying? In the previous one, we have taken only one. Okay, so now in this case, we are taking all the three value and finding out the maximum of the value and we are solving the issues. Okay, so this is how the agreement protocol works in a distributed system. So it is not only in a distributed operating system. That's why I'm saying commonly distributed system. It is not only for a distributed operating system. Even in a distributed database system, the same concept is involved to agree upon whether each and every query, whether you have to commit or whether you have to abort the particular query. So all these conditions is checking based on the the non-faulty or the agreement message happening between the two sides. Okay. So this is the basic understanding of agreement algorithm. I hope you have understood this particular class. Okay. Yes or no? Hello, please respond to me.
Yes, sir.
Hello. What about everybody? What about others?